to have the SpaceX capability to actually return things, unlike the other cargo ships?
Well, to answer your first question, no, we have not brought any samples back since the last shuttle flight. And one of the ways that when NASA knew the shuttle was going to retire, we actually flew extra freezers to the space station to hold those samples so that the crews could continue to collect samples on orbit, knowing that we would bring them back when we had a chance. And the novelty at this point of SpaceX is that this is the first real return vehicle for this type of samples. Obviously, we can get the crew home on the Soyuz, but the cargo capability of the Soyuz is extremely limited. So this is our first set of samples that have come back. So if you want to go back, I guess the oldest samples in those freezers has been since last July.
They all coming back in freezers? Is that?
That's correct. There's actually two different types of freezers we have. One is a typical powered freezer that's known as the Glacier, and that's where all the blood will be. We also have samples coming back in what's called a double cold bag, which is essentially a fancy lunch bag that we don't let them put their lunches in, but it has ice packs in there that after very intensive testing, we've shown that they can stay in there for 3 or 4 days, plenty of time from the point at which they come out of the freezer, go into the bag, and we get them back in our hands in the lab. And these are the same two technologies that we use to bring samples back on the shuttle. It's just now we've adapted them to this other vehicle.
And if I could, one question for Dr. Robinson. Yesterday there was an announcement about, in 2015, 2 crew members spending a whole entire year aboard the space station. What does that mean to your team of scientists? How exciting is that? What can you really get out of it? And what have you learned from the 3 Russian experiences that went that distance years ago?
Sure. Yeah, that's a great question. We've been working across the partnership looking at this for a number of months. In the past, the Russian cosmonauts that have flown for 1 year, they flew at a time when both medical technology was not as advanced as it is today, and also when we didn't have the knowledge that we've gotten from the space station so far about exercise routines and nutrition, some of the things that Scott talked about. So today we're in a position where we think we know a lot more about what it takes to keep a crew member healthy for 6 months in orbit. But we know that for a variety of space missions that are under consideration, we really might need crew members to go a little bit longer. And so we can get a quick look at what we don't know by having a small number of subjects, like the astronaut and the cosmonaut that will do this one-year duration flight. We can collect similar kinds of measurements on them as we do in our 6-month crew members, and it will give us just a couple of data points that will tell us, is the trajectory of what we see happening in the first 6 months, does that continue? Does it level out on a lot of these different parameters? And that's going to really change the way that we look at our long duration research program. So it will immediately feed back into our human research risk models and help us redefine where we need more information, where we're good to go.
James?
James Dean with Florida Today. Ms. Robinson, I don't think hardly any science flew on the demonstration flight back in May. Why not? And at this point, with this mission, does this represent a true full complement of this kind of science you would like to fly, or are you still sort of working up to what you would consider like your highest value cargo as they continue to demonstrate the ability to get up and down?
What we did in May, because it was a demonstration flight and there were some uncertainties, not so much about the success of the flight, but about the ground operations and things, with new teams handling samples, some of which have limited lives, things that are frozen and so forth. We primarily flew samples that we knew were degrading in orbit, and we brought those home on the demonstration flight, and we did launch cargo both ways. But it was, as you say, a slightly reduced complement from our normal full up. This flight is all out, maxed out, really filling our research needs, and this is what we're going to expect SpaceX flights to look like every time they launch in the future.
Thanks. And you talking about down mass, of course, compared to the shuttle. And did I understand correctly? Does Dragon actually, at least from a research perspective, equal what the shuttle could return in terms of capacity?
So it doesn't equal it mass for mass, but we've designed the space station so that we don't really need to bring up and down really large components. So for our research resupply, for keeping the lab running, it gives us everything our users need.
Mark Ratterman with Talking Space for Dr. Robinson. I saw a mention on the
payload list of AMS cables. Is that for replacement or spares, or what can you tell us about AMS?
Yeah, so it's just a spare cable for one that we replaced on orbit.
And another question about iServe, and you mentioned it being the highest resolution device to fly on station for Earth imaging. How does that compare to other satellites and apparatus in orbit that's doing Earth imaging? Is it similar? Is it another step ahead?
So some of the commercial imagers that people buy imagery from, like OrbView, have about 1 meter spatial resolution. So it's not quite as high resolution as that, but for imagery that can be provided to the developing world for helping to solve problems, it's higher resolution. As a comparison, Landsat, which is the other sort of inexpensive data source that's often used as a workhorse around the world, that's 30-meter spatial resolution. So when you're trying to look at droughts or floods, that extra spatial resolution can be really valuable.
Hi, I'm Stacy Severn. I'm with the NASA Social. A question for Dr. Yeatman. You mentioned that there was an unsolicited RFP that came in for protein crystallography. I'm just curious, do we see more of that in the future? Independent corporations wanting research done on the space station?
Well, we certainly hope so. I think by generating interest through solicitations, we obviously generate a lot of advertising for what can be done on the space station, and we hope that unsolicited will come through as well, and we have a mechanism to filter those and examine them. So,
Art Harmon, SaveManSpace.com. 2 quick questions. Why just 1,000 pounds of cargo up and down on this mission? Its capacity is a lot more.
Well, that's not the total cargo up and down, that's the research cargo up and down. So we also have food, clothing, spare parts, all kinds of other things. The flight is full.
Excellent. And a follow-up on the 1-year mission, I believe one of the highest values of the space station is simulating Mars and other deep space missions. Will there be additional, or is it just going to be this one shot in 2015 due to the Russian scheduling of the tourist?
Well, so I want to emphasize that this 1-year decision was made across the partnership for scientific and technology testing value. Mm-hmm. The plan is to do it once and then see what we identify. So, as I talked about, if we're seeing that most of the trends are exactly what we would predict, then we would know scientifically we don't really need additional 1-year missions. But if we see some big surprises come out of our observations of the 1-year crew member, that's going to send us in a different trajectory. So the great thing is, across the partnership, we have an active team that is working on all of these different mission simulations and what should we be doing to get all the knowledge we need from the ISS period so that we're ready to go on to those future destinations. And we'll be able to assess that as we go, as we learn from this first mission.
Excellent. Thank you.
We're going to take one more question here, and then we're going to take a question on the phone bridge, and then we'll come back. So let's take a question here.
Steve Carney with the Florida News Network. Dr. Yeatman, you mentioned the possible collaboration between cases and Big Pharma. I was just curious as to what sort of interest you've generated so far, if any, and what sort of time frame you're looking at for a collaboration to get started and possibly see some effects from it.
Sure. So I think on the website, an announcement was made that Merck has an interest in a particular protein crystallography experiment with a monoclonal antibody, which looks very exciting. I think that as we develop further capabilities, for instance, mouse models to go in space, we'll be able to engage a number of different pharma for various things. One of them is muscle wasting diseases, as we talked about, and osteoporosis is another. We also think stem cells might be an area of interest for pharma as well. So I think the more we can develop and partner with NASA and partner with industry to figure out what they actually need, I think we can entice them. So we're going to build things that they actually can use, not that they might use.
Okay, let's go to the phone line and take a question from Tariq Malik. Tariq, are you there?
Yes, thank you very much. Tariq Malik from Space.com. And I think I have a question that may be either for Dr. Robinson or Dr. Smith. I'm curious how the demonstration flight, what with the launch and then the return, gave you the experience on what to expect in handling the return samples, from a capsule like Dragon, on getting it back from the ocean, getting it back to Houston, and into the hands of your scientists, how that process went, in terms of smoothly, and then also just how important it is to really have maybe a more frequent schedule of samples returning back on a regular basis from either Dragon or in the future Cygnus as well. Thank you.
Sure. So, Tarek, this is Julie. The test went really well. It's actually not that difficult on the ground because what we can do is take the cold bags, these freezer bags, and throw them right in a freezer. That keeps them cold until we get the capsule, until SpaceX gets the capsule to shore. And then we can offload those and transport them back to the users. With the freezers, we plug them in, and we did a test of that to see how well things held temperature. And so we really felt confident that we could bring home these essentially priceless samples, and that we'll be able to do so routinely. It's been a great performance by SpaceX to help us get all of those logistics worked out. And the other great thing is, as we move towards these routine SpaceX flights, we're also working closely with them to add additional capabilities that we may need to support our research community. So, for example, because of the interest from pharma, we know that we need more freezer capacity than we had originally planned, and so we're working to extend that, and that will happen in a couple of flights. Also, as we add more animal capacity to do animal research in the program, we work closely with SpaceX to enable that.
Tarek, do you have a follow-up?
No, that answered my question. Thank you very much.
Okay, thank you. Back here at Kennedy Space Center.
Jeff Faust, Space Review. For Dr. Yeatman, can you give us a timeline for some of these future research opportunities? How soon will some of these possibilities in the life sciences and other areas actually be flying to the space station?
So I think that the timeline is, I'm going to give them the right increments. I think 37, 38 is we're talking about. So not too far away. It gives us enough time to get the RFPs out, sort through some of these experiments, find the best ones, and get them up there. Also prepare the equipment and do all the integration required to get the right equipment up there.
And for those of you who don't speak increment, that's a year away.
Okay. Over here.
Hi, I'm Charles Parker with Brevard Times, and also I'm the director of the Da Vinci Academy of Aerospace Technology at Merritt Island High School. And I wanted to talk, Dr. Robinson, Dr. Yeatman, talk a little bit more about the cost of CubeSats and any collaboration that high school academies, aerospace academies, can do to help us get in space.
CubeSat costs.
Yeah. So certainly the CubeSat example that I talked about today cost about $30,000. There are a number of CubeSat launch opportunities that have been enabled by something we call JSOD. It's basically a little launcher that's on the GEM module. So now what we can do is we can launch these CubeSats in excess capacity that we have at any time. We put them in this launcher. They go out through the GEM airlock on the Kibo module. They can go out. There's a robotic arm that puts them out into this launcher. Well, actually, the launcher comes in and they load it up, and then it goes out. And so it's relatively, crew doesn't take a lot of crew effort, and so it's a great system to take advantage of that. And there have been a lot of different educational organizations that have been working on building CubeSats and have had trouble finding launch opportunities. So it's a pretty good capability to add for both education value, but also for science value. There are scientifically based CubeSats both being launched, that were launched this week, and being under development as well. And just to add for your students, I mean, the big change that's happened in the last year are the numbers of kinds of contests and the rigor with which the winners of those contests have developed their science. So I would definitely encourage anyone from the Aerospace Academy to keep up on those contests and start getting your students to apply.
As it's mentioned, that next year CASIS is going to support a 5-week middle school camp with 3 to 5 locations nationwide, and there's going to be a final middle school competition in August of 2013 for some of these activities.
Mark Ratterman with Talking Space. it's kind of hard to direct this question to one panel member because you've all touched on it, and I know it goes away from where we are right now with what we know and what research has brought us. But might